Well, hello. Here we are. I'm actually at my house and I rigged myself up a document camera, so we'll see how this works. But we're up for 5.7 writing polynomial functions. And before we get into writing polynomial functions in class, we did we spent a little bit of time on Desmos, graphing some polynomials, getting an idea of what those look like, and pretty soon we're going to be graphing those by hand. And going along with that, I want to go ahead and introduce a concept for graphing. We're going to spend most of the focal point of this video will be talking about writing polynomial functions. But again, just to kind of introduce and talk about graphing a little bit, I want to lay down some ground rules. Behavior near zeros. A big part of graphing polynomials will be to determine what all the zeros are. And then once you get those zeros, you're going to be able to determine whether the graph crosses at the zero or if it bounces off of it, if it's tangent to that zero. So that's what I want to talk about right here. So I got a few things I want you to write down. First things first, only real zeros appear as x-intercepts. So when you go to solve your polynomial function and you find all your zeros, and if some of them end up being imaginary, you end up taking the square root of a negative, those zeros will not show up on your graph. The next thing is that zeros appearing an odd number of times cross the x-axis. Zeros appearing an odd number of times cross the x-axis. Now, again, it's not saying that the zero is odd. It's saying that if it appears an odd number of times, it will cross the x-axis. The next thing is that zeros appearing an even number of times are tangent to the x-axis. And the way I think of it, it's not a mathematical term, but the graph bounces at that zero, at the x-axis there. It'll bounce. And again, it's not that the zero is odd or even, it's that the zero appears an even number of times. It's going to be tangent to the x-axis. Now, typically what happens so far when we've solved polynomial functions, when we've found all the zeros, is typically an answer would just show up once. Well, 1 is odd. So when you go to graph, it would cross the x-axis. If an answer happened to show up 2 times, which is what's mostly going to happen for us, so an answer will show up twice. If an answer shows up twice, you get x equals -2, x equals -2. You get it twice. Well, that's even. 2 is even, and it will bounce. So let me draw a couple pictures to illustrate this idea here. Put a 0 to the left of the origin, a 0 to the right. There's our x-axis, our y-axis. And if we have a polynomial function that when we graph it, it comes down through here, loops back up, and comes back down like this. Well, we know that because this crossed, this 0, might have been at like -4. This 0 would have had to have shown up an odd number of times. Right here, it's tangent. It just touches it and turns the other way. It's tangent to the x-axis. That would have had to have shown up, let's say that 0 was 5. it would have had to shown up an even number of times. Twice, 4 times, 6 times, an even number of times. And just for good measure, let's do another one. Put a 0 to the left, a couple zeros to the right. And maybe it comes down like this, bounces off, crosses, bounces off, okay. Kind of a crazy graph like that. Well, the question is, would that 0 have shown up an odd or an even number of times? It bounces. It would have had to have shown up an even number of times. It's tangent to the x-axis. This 0 right here, odd or even? Odd. It crosses. Odd or even? Even. It bounces. It's tangent. So we will spend plenty of more time talking about graphs and how to graph polynomial functions, but I wanted to plant this idea in your brain early on. All right, moving on to writing polynomial functions. What we're going to be doing is we are going to be, let me slide my light over here. What we're going to be doing is we are going to be given zeros, okay? We're going to be given zeros. We're also going to be given a leading coefficient, and we're going to be asked to write an equation, write a polynomial function from that leading coefficient and that 0. But there's a couple things you need to be wary of. For one, the multiplication can be a little bit strenuous, okay? It takes a little while. For two, we have to worry about conjugates. Now, let me see if I got some spare paper here real quick. Yeah, this will work. So, class, let's say you were solving a polynomial function and you ended up with x squared minus 2 equals 0. And it didn't factor down that term, and you set it equal to 0, and you solved it, and you said x squared equals 2. You square rooted both sides, and then you're a good algebra student, so you said, when I square root to undo squaring, I have to do a plus or minus. So your answer is plus or minus square root 2. Well, therein lies the fact that if somebody was to tell you, hey, one of the zeros is square root 2, you would look at that and you'd say, well, wait a second. If you got a square root 2, it makes sense that you more than likely must have also have had a negative square root 2. And that's exactly what we're talking about with our conjugates. If you've got a square root, which is irrational, this is an irrational number. If you've got I, an imaginary number, they resulted from taking the square root of a squared at some point. And you necessarily had a plus and a minus. So back to our notes. It says conjugates of irrational and complex numbers contain I, are also always zeros. So what that means is if x is equal to 1 plus I square root 2, you will necessarily also have x equals the conjugate as a 0 as well. The conjugate is not the opposite. It's changing the addition to subtraction. So in this case, it's not the opposite, I should say. So your conjugate would be 1 minus I square root 2. Let's do another one here. If somebody tells you, hey, mister, you've got 3 minus square root 5 as one of your zeros, well, you're going to say, well, you know what else, buddy? You also have its conjugate as a 0. So they say 3 minus square root 5, you say 3 plus square root 5 as well. Now, just like that little example I showed you a moment ago, this conjugate idea also works if you don't have two separate terms. You just got a square root 3. If you got a square root 3, then you're also going to have a negative square root 3, plus or minus, right? Plus or minus. If you have x equals negative 2i, well, you know what? You're also going to have positive 2i, plus or minus. All right, so let's put this all together. Our example 1 says, write a polynomial function f of the least degree that has rational coefficients, a leading coefficient of 1, and zeros of 2, and negative 2 minus 5i. That is 1, 0 right there. Okay. Now, the part about the least degree, that's what we're going to do automatically. We're not going to make this more complicated than what we need to. And it has rational coefficients. Again, that's something that it's going to work out that way every time. It's nothing that we need to worry about. In other instances, in other classes, you may need to be a little more concerned with that, but not for this class. So we want to write a polynomial function f that has a leading coefficient of 1 and zeros of 2 and negative 2 minus 5i. Well, before I start to write anything out, I'm gonna remember the conjugates issue. If we have negative 2 minus 5i, that's a complex number, it's imaginary, we are also going to have its conjugate. We are also going to have negative 2 plus 5i as one of our zeros. Now we're ready to go. Let me slide this up here just a little bit, make sure I got plenty of room. Yeah, there we go. They said it was going to be called f, function f, so we go f of x equals, your leading coefficient just goes out front. Most of the time it's going to be 1. It doesn't have to be 1. It's just the books get kind of lazy and they just say, hey, for all these problems, the leading coefficient is 1. But I think it's important to know that it could be any number. And then we start writing our zeros. Now, from our zeros to write factors, we're just going to go x minus, and then start writing the zero. So the first zero is 2, x minus 2. If we were going backwards and solving, we would set this equal to 0 and get x equals 2. So we're going backwards. X minus 2. It's always x minus. For our next zero, we go x minus, and then we just write the 0 in. Now, we got to be careful, though, because it's minus that whole thing, negative 2 minus 5i. So we have this awkward sort of parentheses within a parentheses. Don't stress about that too much, but it is something new to you. We also have the conjugates. We do x minus parentheses negative 2 plus 5i. All right, a lot of stuff going on, a lot of weird stuff. Well, from there, class, you want to simplify it a little bit. So we get f of x equals, the 1 isn't going to do anything, so we'll just go x minus 2. And then I'll distribute the negative, get x plus 2 plus 5i, and get distribute the negative, x plus 2 minus 5i. Now, class, this is what we're going to accept as being in factored form, okay? Factored form. Some questions are going to specify they just want factored form. It's usually going to be when you have more than one conjugate to deal with. We're just going to make you do factored form. We're not going to have you multiply everything out. But on a problem like this, we're going to want you to keep going. We're going to want you to write this thing in standard form, a more normal sort of format. So to do that, we just got some multiplying to do. Now, my suggestion is always multiply those conjugate factors. Always multiply those together first, because when you multiply conjugates together, a lot of stuff drops out. So because it's 3 by 3, I'm going to use a box to organize my multiplication. And x to 5i, x to negative 5i. Multiply everything out. It gets a little bit weird. We got i's and x's together. It doesn't really, it turns out you won't have to worry about it for long. 2x, 4, 10i, negative 5ix, negative 10i. And then at the end here, be careful, it's going to be negative 25i squared. Now what you'll notice is you've got some things that are opposites. Also, you may recall that I squared is actually negative 1. Negative 1 times negative 25 is a positive 25. I'll go ahead and mark that out and write a 25. So now let's clean this up. At this point, we've got our x minus 2, but now we're going to have x squared, combine like terms there, 4x, combine like terms, 29. Now that's not quite in standard form. That's kind of more factored form that we're used to without having the imaginary numbers. But we still have one more step to do, and I'm going to use a box yet again. If you recall, anytime I've got 3 terms or more and I'm multiplying, I like to call upon the box to help organize my multiplication. X to the third, 4x squared, 29x, negative 2x squared, negative 8x, negative 58. And our final answer in standard form, x to the third plus 2x squared plus 21x minus 58. And that, my friends, is in standard form. All right. So these are kind of problems where, about a quarter of the class is vocal and they moan, and, oh my gosh, so much stuff. Well, you know what? It's going to stay feeling like it's so much stuff and it's so difficult until you practice it a few times. After you do it a few times, it may still seem like a bit of a chore, but it's nothing to moan and groan about. Well, let's flip this over. Let's do it a little bit more practice here. Let's do another one. It says, write a polynomial function f of the least degree that has rational coefficients. Again, that part you don't really have to worry about. A leading coefficient of 2. Hey, we're mixing it up a little bit. Leading coefficient of 2, zeros of 2i, and 4 minus square root 6. Conjugates. Let's get those out of the way. Conjugates. If we've got 2i, we're also going to have negative 2i. If we've got 4 minus square root 6, we're going to have its conjugate, 4 plus square root 6. From there, we're ready to write everything out. Because we've got 2 conjugates going on, let's just do factored form on this. We'll do one more example that we multiply out all the way. But on this one, let's just go ahead and do factored form. So they're naming it f again. So we got f of x equals leading coefficient of 2, a 0 at 2i. So we go x minus 2i. Go ahead and get the conjugate. It's nice to have them side by side. It'll be x minus negative 2i. If you want to, you can go ahead and write plus 2i if you want to think ahead a little bit. For some people, that's dangerous. Okay, so just be careful of that. X minus parentheses 4 minus square root 6. Again, some people can go ahead and distribute that right away, and that's you can do that, but again, it can be a little bit dangerous for some people. And then we got x minus parentheses 4 plus square root 6. And then let's just take a step to simplify some stuff that can be simplified, and then we'll be done. F of x equals 2, x minus 2i, x plus 2i, x minus 4 plus square root 6, distributing that negative, x minus 4 minus square root 6. And we'll call that one quits. We'll leave it, we'll consider that to be our factored form. Now let's do one more that we actually multiply out. So we'll call it number 3. And we'll say write a polynomial function w with a leading coefficient of -6, just to be different. Normally it's 1, just a heads up. And zeros of -4 and square root 31. All right, let me see. Yeah, I guess I'll stick with my red ink pen here. I like to change colors from what the problem is and then how you solve it. Well, class, we're going to call this thing W. We've got a leading coefficient, -6. We've got some zeros. But because we have that square root 31, we're also going to have a conjugate 0, aren't we? The conjugate, the conjugate 0 of square root 31 would be negative square root 31. And we're ready to begin. It's named W, so we'll say W of x equals, our leading coefficient's -6. Then we start writing our factors from our zeros. So -4, so we'll go x minus -4. Again, you could go ahead and change that to x plus 4 if you wanted to. We've also got x minus square root 31. But we've also got our conjugate for our 0. I'm sorry, we've got a factor for our conjugate. So we got x minus negative square root 31. And from here, we can realize we're going to be adding the opposites right there. And I want you to do this in standard form. So we're gonna do it all the way. Again, you're going to want to multiply the conjugate factors first. Okay, so let's just do that. Since it's a 2 by 2, I'm not going to write out a table. I'm just going to go ahead and do the arrows there. We're going to do that, that. If I wanted to, I could multiply the -6 times the x plus 4, but I'm just going to save that -6 until the very end. So I'll just leave these alone. But then on here, we'll have x times x to get x squared. X times square root 31, we can call it x square root 31 or square root 31x. I don't really care. And then distribute the negative square root 31. Again, we can write that however you want. It's not going to last long. And then at the end here, class, you can grab a calculator if you want, square root 31 times square root 31. But hopefully you're familiar with the fact that when you multiply the same radical, the same square root by the same square root, you're just going to get the radicand. So it's going to be minus 31, like so. Now what happens in here in the middle? Well, you know, same thing that happens with all conjugates. The middle stuff, it drops out. So now what we're left with is wx equals -6, x plus 4, and we have x squared minus 31. Now from here I'm going to multiply these two together. Again, just a personal preference. I'm going to leave that -6 alone. I'm going to get x to the third minus 31x plus 4x squared minus 124. Now, nothing simplifies, but we do need to write things in standard form. So on my next line, as I multiply things out, I'm going to write them in the proper order in descending degree. So we get wx equals negative 6x to the third. And I'll go ahead and do the x squared. Negative 24x squared, now the x. Positive, what is that, 186x. And then negative 6 times negative 124, that's positive. And 744. And that, my friends, is standard form. If you're keeping track up here, after you change the signs, that was the factored form. And here's our answer in standard form. So the, oh, I'm so sorry. Wow. I wasn't displaying the last part there. I sincerely apologize. Well, there you have it. Distribute. Yeah, and there you go. And then finally distribute the negative 6. I talked all through that, but apparently I didn't show it. I apologize. The practice for this is page 384. And it's numbers 23 through 31 odd. But here's the thing. On most of them, you can leave them in factored form. But I'd like for you to do standard form for 23, 25, and 29. I don't know if you guys heard that, but the dog was doing something, probably chasing a cat. Anyway, but yeah, standard form, multiply it all out for 23, 25, and 29. Thanks so much for watching. Have a great day.